Hello. So from today, I will be starting the embedded course. So in this course, I will be taking you through the hands-on with embedded systems. I will be focused more on how to use embedded systems, how to do the development, how to flash in the MCUs. So there will be practical videos on how we are flashing. There will be live coding session on the embedded type on the embedded device, and what is firmware, everything will be known. So I will be starting from very basics and going towards the advanced part in this course. So this course will be divided into multiple sections. So this is the syllabus currently on your screen. So as you see, first I will be starting with the architecture of the microcontroller, going through what is RAM, flash, and instruction sets. So what is the importance of RAM, what is the importance of flash, and what is instruction set. Then I will be focusing on the language, which is also a very important part in the firmware development. So C language, the I will not be teaching you the C language, but it will be a brush up on the very important topics that will be mostly used for embedded development, like storage classes, structures union, functions, and pointers. Next, we will be looking into embedded code. So in this embedded code, we will actually be writing the code in the development boards. So I will be using this kind of development board for this tutorial video. Okay, on this board only we will be doing all the coding. I will be showing you how to flash in this board, how to read the memory structure in this board. Everything will be done using this board. This is an STM32F4 series evaluation board. You can also get it from Amazon. Okay, next things are, we will look into communication part. After the embedded is finished, we will look into communication part. So in communication, mostly we will look into three things: UART, I2C, and SPI. So after these are over, then only we will look understand what is debugger. And at the end, there will be a bonus section where I will be explaining you what is bootloader and how we handle bootloader coding. Okay. Okay, even before going into MCU architecture, let's understand what actually is the embedded system, what is firmware, and how this changes the world. Okay, so let us consider a very simple circuit. So we have a battery having a plus and a minus, and one simple LED that is also having a plus and a minus, correct? And a normal switch. So if I connect the switch like this is connected directly to here, and the positive section is connected here, and you have a clock here. Okay, now I tell you, whenever 60 minute is complete, means after every 1 hour, I want this LED to glow. Okay, and after every 1 hour, this LED should glow for 30 seconds, indicating that 1 hour is done and it should switch off. So how you can manage this has to be first managed practically based on somebody is there who is turning on the switch on and off by his hand, and then this is managed. Okay, so this is, I would say, manual, correct? So this person has to look into the watch, keep a track for every 60 minutes, then come back and toggle the switch. Then again he should have to look for another 30 seconds and then turn off the switch, correct? So this is a manual task. Now let's automate it. How we can automate? Let's see, let's say we do connect this to a relay circuit, a magnetic relay circuit, and then connect it to the this watch, that whenever this watch shows after every 1 hour, whenever this clock hand reaches 12, then it should glow, or after every 1 hour this should glow, some mechanical circuit like that, like there is like how our old wall clocks toggle, like that. So this is also a relay based circuit. Okay, now this has a flaw that if this watch is dependent on a battery, and this is also dependent on a battery. If this battery dries, then this circuit is of no use. So now what we do, we make a logical circuit. Okay, we remove the entire clock from the scenario, and what we do, we introduce a small transistor in the circuit like this. which is a switch, nothing but a switch. So this is a BJT, and this BJT we operate from a MCU, and in MCU we just like a simple program that after if clock equals to 60, let's say this is P1, so P1 equals to high. Okay, and this clock is maybe a integer which will increase, like this clock can be a integer which will plus plus after every 1 minute, and when it enters here we can just say clock equals to 0, also resetting it. Simple logic, but it will work every time. Why? This MCU will be counting this 60 and working. So what MCU is having? A software part which is controlling this P1, which is a pin, which is a actual hardware pin. Okay, so this one, if you look into this, so these are the pins which will be connected, and these pins you can control using a code like this C code. You can control the pins. Okay, so this is what is there in the embedded systems. So in embedded you have a hardware plus a software, but both of them are connected via we call at hard HAL, hardware abstraction layer. So what HAL does? HAL directly connects the hardware to the software. Okay. Now going forward in the architecture, we'll understand how the software actually interacts with the hardware. Okay. Okay. Now let's focus on to this. This is the board which I was showing you. Okay, so these are the hardware pins. Okay, these are the pins, these are the pins. You can see here it is written as D5, D4, like that. So these are the pins which you can control using the microcontroller actually. Okay, now let's understand the various part of this microcontroller. So this is the main MCU, this is the main chip or IC or a microcontroller which is controlling the entire circuit board. This section of the board, okay, this section of the board is called the debugger. So this also has a microcontroller that is supporting the debugger functionality, and this is a debugger which will help us to debug this microcontroller after flashing it. And this is the main MCU. Okay, these are the pinouts, and these are some user buttons. This is reset. What reset does, like it will restart the entire program from the beginning. Okay, and some onboard LEDs are there to check the status. Okay, so this is whole and all for the board. So just remember, this is the main MCU which on which we will be focusing. And you could see this small pinouts, right? These pinouts are nothing but these are only connected to, these pinout are taken out and are put as a outside connector to on this board. Okay, let's now understand the architecture of a memory and the different types of memory in an MCU. Okay, so basically the MCU has two types of memory. One is RAM and another is flash. Okay, we'll understand what is RAM and flash and how they are different. First, let's understand the design of a memory unit and how does a memory works. So first thing, in embedded also the data is kept in form of 0 or 1. So any memory unit can either store 0 or it can store 1. So just remember, any unit of memory, when we say, it is always 1 byte and it contains 8 bits. So the smallest memory unit in an embedded system that you can access and utilize is 1 byte of data. Okay, now these are having a starting address. So I have written 0 cross 0 is the starting address. So when you start filling the memory unit, you can start filling it with 0 1 1 0 0 0 1 1. So this is how one memory unit is filled for this byte. Okay, similarly this is the next memory unit which can be filled. And always remember that memory will be filled in this sequence only. So the filling will start from here, then it will start from here, then it will start from here. Like that, the memory unit will start filling. Now let's focus on this one particular block, what it is having. So it should have some kind of method to store 0 or 1, correct? So how they can store? Either it can store 0 and 1 using a capacitor. So if a capacitor is charged, then we call it 1, and if it is discharged, then we call it 0, correct? Or we can store it in the form of a transistor. So if the transistor is on, if it is on, we call it 1. If it is off, we call it 0. Based on these two types, we have two types of memory system. One is capacitor based, another one is the transistor based. Capacitor based is slow because it requires a charging time for capacitor, but transistor based is fast. Okay. Now, this memory units can be of magnetic strips. So if that magnetic strip has a bulge, then we call it as high or 1. If it has nothing, then we call it as 0, like that only. So in this simple example of one memory unit, the type with which the memory unit is made of can segregate it is the difference between a RAM and a flash. Normally flashes are can be written only once or after they are erased, but RAM can be written multiple times. So RAM are mostly made up of either capacitor or they are made up of transistors. So if it is capacitor made, then you know the name, that is DRAM, and if it is transistor made, then it is called SRAM. So I hope it is clear, like every data is either stored in form of an electrical signal, either in a capacitor or in a transistor, or in form of a magnetic strip which has a bulge out. Okay, so magnetic strips are mainly used in hard disk, HHD, that is hard drives that uses the magnetic strips. And the data is always stored in bytes, and 8 byte constitute one, sorry, in form of bytes, and 1 byte constitute 8 bits of data. And every data structure will have a starting address from where the data will start filling. You cannot access the middle, you only have to access the starting address of every bit. You, if you want to update a fifth bit of this one, then you have to access this entire structure of 8 bits, and then you need to update this bit. Okay, RAM can be of SRAM and DRAM, and RAM are very fast. So just for comparison, RAM are 3000 times faster than flash. Okay, and as you see that 1 g, if I give you an analogy, like 16 GB of RAM costs 6000 rupees. Similarly, 1 TB of hard disk also costs maybe 5 to 6000 rupees. So that's the difference, you see. So MCU will have a processing unit, we call it P as a processor, that will be connected to RAM, okay, via bus. So these lines are called bus, and this RAM is will be connected to the flash. Okay, and this RAM will be having the stacks that you may have heard: heap and stack. Okay, so what will happen when you try to run a program? The program will be copied to RAM. First the program will be copied to RAM from the flash, and then the processor will process the program based on the program you have written. If you have declared a variable, then that will be declared in the stack. And then if you are assigning some memory location, that will be memory will be taken from the heap. Like that it will be done. Okay, so just remember, processor access the RAM and RAM access the flash. Okay, now this is the flash architecture of an STM32F4 device. So you see here, this also utilizes an SRAM. Okay, and the total flash size of a typical microcontroller is 128 KB, that is kilobits. or I have seen mostly we use in industrial purpose 96 kb. So this much only RAM is available for you to process, means this much you can utilize to make variables and process it at a time, at a moment. Okay, so let's look into the architecture of RAM. RAMs like SRAM. So SRAMs are basically made of transistor, which I told you, and these are fast. Remember, these are fast, then costly, and also they are long lasting. Okay. Now the next part is this one, DRAM. DRAM are made of capacitor, so they are slow, cheap. So if you have any doubt, you can ask me. Just remember, RAM is the memory that will be utilized by the CPU to process the data and to run the program. Okay, if you don't have RAM, then your program cannot be run. So RAM is required to run the program and process the data. Now flash. Remember, flash is that portion in an MCU where your actual code will be placed. So whatever C code you write, .c or .h code you write, that will be converted into .o, and that will be placed in the flash area. Okay. Now one very important thing that you need to know, that the flash is divided into sectors. So what is meant by that? It means that you have the entire microcontroller like this, and you see here the flash will start from 0 cross 8 8000 800.8000, like 0 cross 8. From there only it will start. So why this is not starting from 0 cross 0? Because 0 cross 0 is the starting address of the RAM. So once this RAM is having the starting address of 0 cross 0, after that the flash starts. So that's why the flash is here. Now what is the thing? The the flash is divided into sectors. So divided, so this is sector 0, this is sector 1, sector 2, 3, then 4, like that. So now what is the importance of the sector that we need to understand? So whenever we want to write something to the flash, okay, so if you want to update something to this portion of the flash, let's say you want to write some data at 0 cross 004000. From this address you want to write a data that is 123. Now to write the data into this address, you need to access the sector 2. And if you have written 123 in the sector 2, this is, I can say, this is a this can be done using 1 byte of data. Okay, and for that you will be utilizing bits after this, like 8 bits can be used. Now if you just want to change 1234 to 123 sorry 124, that is only changing this bit. For that also you have to delete or erase the entire sector, then only you can update this 8 bits. Yes, that's the main catch here. Whenever you want to write something to the flash, you can only write it once it is erased. So to write something to the flash should have been erased first. Then we need to unlock the flash. Then we need to write. Then we need to lock the flash. So this is the sequence it is followed, and you cannot erase 1 byte of data. You cannot erase 1 bit. No, not possible. You cannot erase 1 byte. Not possible. You have to erase the entire sector. You have to give which sector you want to erase, so the entire sector will be erased, and then only you can rewrite the data after unlocking the flash. So that is the catch here. Why these all are done? Because flash is not very dynamic, it's a static. Okay. Okay, this is the architecture for the entire microcontroller. So here you have the CPU, then this is the flash, and this is the SRAM. These are the bus via which this CPU talks to the SRAM, and this is the file system which will help the flash data from the flash and copy to the SRAM. Okay, then these are the DMA, that is direct memory access, and DMA1, DMA2, and then there are two buses, that is ABP1 and ABP2. Now one more thing, the MCU requires a crystal. Now you will say, what is a crystal? Crystal is nothing, just an oscillator. So what happens, it is like the heartbeat in our body. So this crystal oscillator only gives these pulses like this, and this pulses helps the microcontroller to run or to function. Based on this oscillations only, the instructions will be executed. Some microcontrollers may have a crystal oscillator. We call it an external crystal, or we can have an RLC circuit, or we can have a capacitive RC circuit. Mostly RC circuit is inbuilt, so this is an internal oscillations will be generated by an RC circuit. Based on that, the oscillations will be carried out. So I hope this is clear, that every microcontroller will be having a flash, an SRAM, a controller, and the bus which is connecting them. And then you have a crystal oscillator that will be generating the pulse that will enable the microcontroller to work. So in next topic, I will be explaining you C language, and also I will be covering the instruction set. What is the instruction set is there? Okay, so any question you can put it into the comment. Thank you.